Another integration by recognition here. This one is a little trickier than some of the previous ones, but most of the rules are the same. So we'll jump into it. It says differentiate x times cos x, or x cos x, and hence find an antiderivative of x sine x. All right, so jumping straight into it, we have, well, we can let y equal x cos x. Real question now, because we have a function x times another function cos x. So I'll call that u and I'll call that v, which means that u is equal to x and u dash is equal to 1, and v is equal to cos x and v dash is equal to negative sine x. And so that means that y dash will be equal to u v dash, so x times negative sine x, which would be negative x sine x, uv dash plus vu dash plus vu dash. So u dash is 1 and v is cos x, so just cos x. Okay, there's the first step. We've differentiated x cos x to be y dash equals negative x sine x plus cos x. Now, when it comes to integration by recognition, our next step is to say that the integral of negative x sine x plus cos x with respect to x is equal to whatever we just differentiated, which is x cos x. Okay, so normally in this situation now, find an antiderivative of x sine x. Normally in this situation, this looks pretty close to that. And you can see it does. There's negative x sine x out the front here, but there's also this positive cos x there, which is causing me an issue. So what I can do is get rid of that positive cos x, and I'm going to do it in the following way. Different color pen, because this is sort of the new part of the video. I can say that the integral of negative x sine x plus the integral of cos x, and that's with respect to x, and that's with respect to x as well, equals x cos x. So I've just taken that, the integral of that entire function, and I've said it's equal to the integral of the first function plus the integral of the second function. Okay, so this first bit's still a little bit difficult to do, so I'll just leave that for now, negative x sine x with respect to x. But the integral of cos x is actually really easy. It's just sine x. So you need to be careful here because I've integrated this first part, which is why I still have that with respect to x. But this bit is integrated, equal to still x cos x. All right, so you can see I'm pretty close to the mark here because it says find an antiderivative of x sine x, and this is negative x sine x. And now if I move that, or if I subtract sine x from both sides, I'm going to have something that looks really, really close to the mark. Different color, just because. The integral of negative x sine x with respect to x equals x cos x minus sine x. So that sine x has moved over, that sine x has moved to there. So I'm pretty close. I want the antiderivative of x sine x. Now I have the antiderivative of negative x sine x. So that's sort of the last-ish line. X sine x with respect to x equals x cos x minus sine x. And to get rid of that negative, I can just multiply both sides by negative 1, and I'll get the integral of x sine x with respect to x equals positive sine x negative x cos x. So it's not a whole lot different to some of the questions that we've done in the past. It's just that when you get to this stage, one of those terms looks very, very close to that. The other term you need to get rid of. And the process from, I guess, from that line to that line is how you get rid of it. Integration by recognition part 2.